Okay, so the first step to find all the zeros of a polynomial is list out all the possibles. Since the last coefficient's -1, the leading coefficient there is 1, so it's going to be 1 over 1. The only possible rational, this is the list of possible rational solutions. It's just plus or minus 1. Okay, so the next step is to graph it in your calculator. So get your calculator out, go to a graph screen, graph the function. And it does seem to cross at 1. If you're not sure there, you can hit menu 5, 1, trace over there, find the 0 at 1. It does look like it has a 0 at 1. So we're going to do synthetic division. That's the next step. So once you find your rational 0, only the rational zeros from there. Be careful with this one, by the way. So x cubed, there's a 1 there. There is no x squared. There is no x, and then there's a -1. So don't forget with synthetic division, you've got to put those zeros in there if it's missing some terms. So let's do synthetic division. Let's see what happens here. Remainder is 0. This is your constant. This is your x term. This is your x squared term. So we have now a quadratic, x squared plus x plus 1. You set that equal to 0 and solve it. If you could factor that, you would, but I don't think it's going to factor. The reason I don't think it's going to factor is the only solution really there is 1. So I'm expecting these other two solutions to be imaginary. Remember, imaginary answers come in pairs, and that's what I'm expecting here. So I'm going to do the quadratic formula. So x equals the opposite of b, it's the opposite of 1 over 2 times 1. Oops. Square root of b squared, which is 1 minus 4 times 1 times 1. So we get -1/2 plus or minus the square root of -3, which is that's an I root 3 all over 2. And so those are two of my answers, and my other answer is that one. We have three answers. Two of them are imaginary, one of them is nice and rational. As a side note, this just might be interesting to you. So as a side note, let's just talk about this, because if you had tried to solve this another way, I know I really want you to solve it that way when doing these kinds of problems. But let's just say, I'm not sure if we've talked about this before, but if you just set that equal to 0, so x cubed minus 1 equals 0, and you solved it, you got x cubed equals 1. Take the cube root of both sides, cube root of that, x equals actually positive 1. You only get the nice rational solution. You don't get the imaginaries if you try to if you just solve it that way. In this case, if you had factored it, so do difference of squares, so this is x minus 1, x squared plus x plus 1, and now you'll get both solutions. You get x equals 1, and then if you do quadratic formula like we just did on this, you get the two imaginary solutions. So factoring is a much more powerful way to do it. Again, I don't really need you to do it that way. I need you to get the rational solution from the graph, synthetically divide it out, and get it down to a quadratic. And that's going to be really important on this one that we're about to do here. So on this one, again, I want you to go through the steps. So because the leading coefficient is 1, it's going to be all divided by 1. So really in the top here, my possibles are just factors of 26. So 1 and 26, both of them plus or minus. 2 and 13. 3 doesn't go into 26. 4 doesn't. 5, 6, 7, 8, 9, 10, 11. That's really it. So there's just 8 possibilities. Those are the possible rational zeros. Go ahead and graph that. When you do, I think the graph, I think the graph is going to look like this. So it looks like it crosses at 2 and -1 there. So looking at the graph, it crosses at 2 and -1. So I know two of my answers. So I have a solution of x equals 2 and x equals -1. It doesn't matter which one you choose first, but we're going to synthetically divide both of those out. And we're going to try to get this thing down to quadratic. So once I get my first answer, I'm going to divide out of that one to get it down to quadratic here. So first I'm going to divide out of 2. The nice thing is you know the answer is going to be, the remainder is going to be 0 here. There's no missing terms, it doesn't look like. Okay, so we get 1, 2, -3, -6, 9, 18, 13, 26. Phew, okay. Remainder is there. And now we're going to take that answer and we're going to divide out the second one. So to put a box right here to the left of the answer, go only up into the remainder there. Do not draw the line further than that. And put -1 in the box this time. So this should bring it down to quadratic. And when we do this, we get -4, 4, 13, -13. This works. Remainder is that. This is x, and this is x squared. And just look at the graph. You can see it doesn't cross the x-axis anywhere else. So I'm expecting this is when I do quadratic formula for this to give me some imaginary solutions. So let's see what happens. So x equals, the opposite b would be 4 over 2 times 1. Square root of 16 minus 4 times 1 times 13. See, 4 times 13 is 52, 16. You could use a calculator for this if you need to. So we think we get -36 here. So we get x equals 2 plus or minus the square root. This is really inside of there. The square root of -36 is 6i. So 6i, that's a 6 there, over 2. So we get 2 plus or minus 3i when you cancel. So those are my imaginary solutions. Again, we already got our 2 rational solutions there. So probably fourth degree are probably the toughest ones to do just because you have to do synthetic division twice. Once you get the hang of this, though, it's not too bad. Let's do one more. So again, list out the possibles. These are easier ones because the leading coefficient's 1, so I'm dividing by 1 here. So factors of 15 divided by factors of 1. So you get plus or minus 1, plus or minus 15, plus or minus 3, and plus or minus 5. I think that's it. Go ahead and graph this in your calculator. When you do, you're going to get something that looks like this. You can probably see that the solution looks like an x equals 3 right there. So I'm going to divide out of 3 and see if that works here. You would check it with trace probably to be sure, but I think that's right. 1, -7, 17, and -15. So 1, 3, -4, -12, 5, and positive 15 actually. 0. So remainder 0. And we get x and x squared. It doesn't cross anywhere else other than here, so I'm expecting some imaginary answers when I do quadratic formula here. So let's see what happens. X equals, the opposite of b is 4 over 2 times a. B squared is 16 minus 4 times 5. So 16 minus 20 is -4, so I get 2 plus or minus square root of -4 is 2i, so 2i over 2, which is 2 plus or minus I. Those are your 2 imaginary answers. Again, we already got our rational answer of 3. Because we have a couple extra minutes here, I'd like to do the PSAT. I think this is a really good one to think about. So which one of these, first of all, when you look at this data, is it linear or is it exponential? I know we haven't studied exponential, but you've studied that maybe in science class. You've seen exponential growth or exponential decay potentially. You know about linear. Linear means the same rate of growth. So like the x values are increasing by 5 that seems linear. The y values are increasing by differing amounts. So it goes up by 900, then 9,000, then 90,000. So I think linear is out because they're growing a little faster than that. And they're definitely growing, not decaying. This data is getting bigger. And so the answer has to be C here. Just want to talk about that one just because they love those kinds of questions where you look at a table and say, what's this graph going to look like, kind of a thing. If you graphed it, the graph would look roughly something like, like this. It's going to go up pretty fast. That's what an exponential graph looks like. This exponential growth going up really fast there. Okay, that's the end of the screencast.